Welcome back to Table Talks. Thank you for subscribing to the website. We're still looking at numerical problems to do with projectile motion. Now this is our problem tonight. The problem says that a particle is projected at a point O with an initial speed 30 meters per second to pass through a point which is 40 meters away from O and 10 meters above O. Show that there are two possible angles for which this is possible. Hence, find the angles. So now, let's look at the solution. Now, I said the first thing we do, we must first sketch. If this is our projectile and this is our angle of projection, this projectile is moving with an initial speed of 30 meters per second according to the question, and then they are saying that it passes through a point which is 40 meters away from O. So assuming this is our 40 meters, assuming it is up to there, and 10 meters above that, around here we have 10 meters. This is the height. Where now they're asking us to find the possible angles here, but let's first correct the data here. We see that our U is 30 meters per second. X, or the horizontal range here, is 40 meters, and the vertical displacement is also 10 meters. I think this is the only information that we have. Now what do we do here? We are going to use, we shall say, since they never told us the name of the angle, we shall say let the angle be theta. Okay? Now, having let the angle to be theta, we are going to use the equation of a trajectory that we have, with the equation say that y is equal to x tan theta minus gx squared into 1 plus tan theta squared, the whole thing over 2u squared. This is our equation. That is the equation of a trajectory. And let us now substitute in our y is 10 is equal to the horizontal range, which is 40 tan the angle of projection theta minus 9.81 times the horizontal range, which is 40 squared, into 1 plus tan theta squared, tan theta squared. The whole of this is over 2 times 30 squared. Now that is our expression. We get our calculator and try simplifying. This gives me 10 is equal to 40 tan theta minus 9.81 times 40 squared. This gives me 15,696 into times 1, we get that value. Then again this same result times that, we shall get the same result, which is 15,696 tan theta squared out of 2 times 30 squared. This one we get 1,800. We simplify further by saying 15,696 divided by our answer. Here we see that this is 10 minus 40 tan theta minus 8.72. The whole of this, because this is common, when you divide the whole of it, we get 8.72 tan theta squared. Now, we see that this is some kind of quadratic equation. Let us rearrange. This one crosses equal sign. When it crosses equal sign, this one becomes 8.72 tan theta squared minus 40 tan theta plus 10. This should be equal to 0. Now this is a quadratic equation. When we let tan theta to be x, assuming we say let tan theta be x, it means that our equation is of this nature. Okay? Our equation will be of that nature. Now, solving the quadratic equation, and now we know that for real roots, if we solve this quadratic equation, we should be in position to get two values of x, and those are the values of theta. Now, if we solve this quadratic equation, we should come up with two values of x. Now, these two values of x, we should find their tan inverse. Like one of the values of tan x from a calculator. Let me try to calculate. Let me get a better calculator here that has all the functions. Now, when I calculate these values of tan from the calculator here, let me hope you know how to solve quadratic equations using a calculator. So now, when I press these values in my calculator, the values of tan I get, one is 1.05, and the other value of tan is 0.52. Now, these are the values of tan, or which we call the x. So now I said, hence, find the angles. Now we know the values of tan, so next is getting the possible angles. So now how do we get this angle here? We get the tan inverse. We say tan inverse of 4.05. So one of the angles is 76.1 degrees, and also the tan inverse of 0.52. This one, the other possible angle is 27.5 degrees. So these are the two possible angles, and this being a quadratic equation, okay? This being a quadratic equation shows that it is true. There are two possible angles of projection. So that is this example. If at all you are faced with such a challenge, that is how you should go about that challenge.